Alright, now we will learn what horizontal asymptote mean. The line y equal to b, that means the horizontal line y equal to b is said to be horizontal asymptote of the graph of a function if f of x approaches b as x increases or decreases without bound. What does it mean by that? Let's try to see on this example. So I have a function here. This is again a rational function where a polynomial we have in the numerator, and then 4x squared plus 1 is in the denominator, right? So, and then this is the graph of that. You can see I have a straight line here, y equal to 0, that dashed line. Whenever you can see here, whenever x is getting larger and larger, the function is actually getting closer and closer to that line, right? So over here you can see that line y equal to 0. Whenever x is getting smaller, x is getting smaller and smaller, we have this similar type of behavior. I mean, only one, it's already sufficient for this line to be horizontal asymptote from the right hand side type of phenomena. But you can see here, even when x is getting smaller and smaller, the value is getting closer and closer to 0, and then like getting closer and closer to 0, right? So that's why this is clearly the horizontal asymptote. Now we'll try to learn how to determine horizontal asymptote of a rational function. So let's consider a rational function, right? The numerator polynomial is represented by n of x. The denominator polynomial is represented by d of x. Our goal is just now to see how to find the how to determine the horizontal asymptote, and it's very easy. What you just need to know is how to find the degree of the numerator and denominator polynomial and just compare that. So if the degree of the numerator, whatever is that, if that is less than the degree of the denominator, then y equal to 0 is the horizontal asymptote. The nice example is this one, right? So you can see the degree of the numerator is 1, the degree of the denominator is 2, 1 is less than 2, so clearly y equal to 0 is the horizontal asymptote. Done. If the degree of the numerator is equal to the degree of the denominator, right, so in that case we have whatever is the leading coefficient of the numerator polynomial, whatever is the leading coefficient of the denominator polynomial, just take a ratio of that, and y equal to that ratio will be the horizontal asymptote. For example, you can see here we have a numerator polynomial 3x squared plus 3x minus 6 whose degree is second. The denominator polynomial also has the same degree, so in that case 3 over 2 is the ratio of the leading coefficient. So y equal to 3 over 2 will be the horizontal asymptote. Do you want to check that? Okay, let's go ahead and then do that on the Desmos. Y is equal to, what was the polynomial on the numerator? 3x squared plus 3x minus 6. 3x squared plus, what was that? 3x minus 6. So 3x minus 6, and then divided by, what is the polynomial on the denominator? 2x squared minus 2. 2x squared minus 2. What did I say earlier? To find the horizontal asymptote, we just need to look into the degree, and if they are same, like say this is second degree polynomial, this is second degree polynomial, so we just take a ratio of the leading coefficient, which on this case is 3 over 2. So y equal to 3 over 2, whatever line is that, I want to draw this line in a dashed line, so you can clearly see that dashed line is actually the horizontal asymptote. That's exactly we are seeing here also on the graph. All right, the third case is if the degree of the numerator is greater than the degree of the denominator, then there will be actually no horizontal asymptote. All right, let's find the equation of the horizontal asymptote. Let's take one example where we have f of x is equal to 5x cubed plus 2x minus 3 divided by 6x cubed minus 7x plus 1. So our goal is to find the equation of the horizontal asymptote. As we have discussed earlier, to find the horizontal equation of the horizontal asymptote, we need to check the degree of the numerator polynomial and the degree of the denominator polynomial. We can clearly see that the degree of the numerator polynomial is 3, the degree of the denominator polynomial is also 3. In that case they are same, right? So degree of the numerator polynomial is equal to the degree of the denominator. So if we have that, then y equal to whatever is take a ratio of the leading coefficient, which is what is the leading coefficient of the numerator polynomial? 5. What is the leading coefficient of the denominator polynomial? 6. So 5 over 6 is the ratio of the those leading coefficients. So y equal to 5 over 6 is the horizontal asymptote then. All right. Okay, so now let's try to take another example where we have a function f of x is equal to x to the power 4 plus 2x square plus 1 divided by 1 minus x to the power 5. We do the same thing, check the degree of the numerator polynomial, check the degree of the denominator polynomial. And you can see here is 4 on the numerator, that is the degree of the numerator polynomial, the degree of the denominator is 5. So 4 is less than 5. On that case, what will happen? Then only y equal to 0 is the horizontal asymptote. So if the degree of the numerator is less than degree of the denominator, then y equal to 0 is the horizontal asymptote. Okay, let's take one more example. Well, let's assume we have a function f of x is equal to x square plus 6x plus 1 divided by x minus 5. What is happening here? The degree of the numerator polynomial is 2 and the degree of the denominator polynomial is 1. So 2 is greater than 1. On that case, degree of the numerator is greater than the degree of the denominator. So then we don't have no horizontal asymptote. So we write down no horizontal asymptote. Okay,